Liking this video will help this channel to grow. So please go ahead and give this video a like. As we look further in our lesson on linear equations, this section will cover solving linear equations involving fractions. If you're just joining our BBN family, let me welcome you to this amazing math platform where we seek to sharpen your mathematical skill while igniting your passion for the subject. Guys, feel free to like, comment, and share these videos with as many people as possible. Now, you should have already grabbed your pen and your notebook, so let's begin. Now, when we're solving linear equation with fractions, it is very important to note that fractions are divisions. This means that if fractions are divisions, we're looking for doing the inverse of that, which is multiplication. However, I've listed a few more steps here because it can get a little bit more technical than just doing one step with a division. There are times when we will need to also find the lowest common multiple, which we will look at as we get further. So, to solve equations involving fractions, we follow the steps below. First of all, we remove the fractions. This means we multiply the entire equation by the lowest common multiple, or we could say least common multiple, to remove the fractions where this is applicable. Now, second step is to simplify. So to simplify, we remove all brackets and other grouping signs and combine our like terms. Step 3, we solve the variable using the inverse of operations to move variables to one side of our equation, as you would have seen in section 1 and section 2 of this lesson. Step 4, we solve the variable using appropriate operations. Beautiful. So we basically have all the steps from part 1 and part 2. It's just that now we are given fractions and we will have to apply lowest common multiple where necessary. Beautiful. So we're going to start with some simple example first of all. Here we're asked to solve the following equation showing all our working. First one we're given is x divided by 2, or we could say x halves is equal to 6. Important to note here, let me just rewrite the question, is that we are doing division by 2. By now we know we have to do the opposite of our operation on both sides. So I'm going to go ahead, we need to do the opposite of dividing by 2, which is multiplying by 2. These two divide into each other, leaving us with just x equal to 6 times 2 is 12. Clearly, we can see that 12 divided by 2 gives us 6. So again, usually another 1 marker. This is just dependent on my knowledge of my timetable. Very simple question there. For the next question, where we've got x divided by 5 add 3 is equal to 7. Recognizing here we've got, so let's put this for this question, have, and what we need to do. I've got a plus 3, so I need to minus 3, and then I've got the fractional part, which is a division by 5. I will then need to multiply by 5. So first step is to subtract 3. So I've got 5x divided by 5 equal to, so these two cancel out each other, so 7 take away 3 is 4. So I've done this bit. My next step is to multiply by 5. So x is equal to 5 multiplied by 4, so therefore x is equal to 20. And I can check that quickly. If I put 24x, 20 divided by 5 is 4, and 4 add 3 is equal to 7. Clearly, I know that I am correct. Absolutely brilliant. Now, For this question, we've got x plus 2 divided by 4 is equal to 5. So again, I need to write what I've got, what I need to do. So I have a division by 4. So division by 4, I need to multiply by 4. And then I've got a plus 2. So I'm going to need to minus 2. So let's go. So first thing is to multiply by 4. So times by 4 this side, times this side by 4 as well. These two 4s will cancel out. By now we know this. So we know on this side we will just have x add 2 equal to 5 times by 4 gives me 20. Now I've done this, I need to subtract 2 from both sides. So let's go. So I've got x left since positive and a negative 2 cancels out. 20 take away 2 is 18. Now I can check, quick check. X is 18, so 18 add 2 is 20, and 20 divided by 4 does give me 5. This is how I know for sure I am correct. Beautiful. Now for the next question here, I can take two approaches to this question. I've got that x divided by 2 should be equal to 3/4. Now for this question, again, I can recognize here that I am dividing by 2. And if I'm dividing by 2, I will now need to multiply by 2 on the other side. Another way to do this is by cross multiplication, because I could just cross multiply and do 4 times x and 3 times 2. So 4 times x is 4x, and that's equal to 2 times 3, which is 6. What I now need to do is to divide by 4 on both sides. So again, this side simplifies to x equal to 6/4, or if I could divide this, halving both of them will give me 3. 6 divided by 2 is 3, and 4 divided by 2, which is equal to, so x is equal to, I could write that as a decimal as well. 3/2 is the same as 1.5. So either of those approaches could work, or I could go for the fractions where I do 3/4 divided by 2, which is the same as 3/4 multiply now by a half by keep, change, and flip if we apply the principles that govern fractions. But we could just simply cross multiply to get that out of the fraction to a straight line. Beautiful. Now we go for the next set of examples. Again, we are solving this for x. So I'm going to rewrite my question. 3x divided by 5 add 2 is equal to 8. So again, in my question, I've got, so I have positive 2. I'm going to subtract 2. I have division by 5. I'm going to now need to multiply by 5. And also, if you check here, I've got a multiplication by 3. So somewhere I will need to divide by 3. So let's follow the principles. So first step is to subtract 2 from both sides. So doing this one, I've got 3x/5 equal to 8 minus 2 is 6. So I've done my subtraction. Now I need to do the opposite of dividing by 5 here, which is to multiply by 5. So multiply by 5 on both sides. We know that these 2 will give us just 1. So we just have 3x left equal to 6 times 5 gives us 30. So I've completed this bit here. Now I need to do the opposite of multiplying by 3, which is dividing by 3 on both sides. So therefore, 3x divided by 3 is just x, and 30 divided by 3 is 10. So therefore, x is 10. So guys, as you can see, once I write the operations I've got in the question and what I need to do, I just need to apply them one step at a time in the correct order. take care of our constant first, or the operation that was done last. So what had really taken place in this question, we multiplied x by 3 first, then divided it by 5, then add 2. So to solve it, we start from the last. We need to take care of the addition by 2 by doing subtraction. Then the second to last thing that was done is dividing by 5. So we need to do the opposite, which is multiplying by 5. And then the first thing that was done, we will now do last, which is multiplication by 3. We reverse that with division by 3. The order matters. It does. Okay, moving along to our next question, where we are given 1/2 should be multiplied by x at 4, and that result is equal to 6. So again, we go for what we need to do first. So let's write down what we've got in the question and what we need to do. So we have a multiplication by 1/2. So times 1/2, we're going to need to divide by 1/2, which we could write as 0.5 as well. Then we've got in bracket here an addition of 4, so we're going to need to subtract 4. So first thing we've got to do, in order to get access to x, we've got to take care of that half first. So I'm just going to write it here as 0.5 to make it easier for you. So I'm going to write 0.5x plus 4 is equal to 6. So we're dividing both sides by 1/2. So dividing this by 1/2, we will just have this cancelling out, leave us with x plus 4. Remember, dividing by 1/2 is the same as multiplying by 2. So 6 divided by 1/2 is actually equal to 12. Beautiful. So now that we've done this bit, we now need to take care of our plus 4 by doing the opposite of that, which is minus 4 from both sides. So here we go. This cancels to be just x here. Since minus 4 plus 4 is 0, we've got just x left, and then 12 minus 4 is 8. So x actually is 8. And again, check your answer. So 8 here for x plus 4 is 12. Half 12 is 6. This is how I know for sure that my answer 8 is correct. Beautiful. Take opportunities. Make sure you prove your answers. Absolutely fantastic. Now we're going to do 2 questions that involves finding the lowest common multiple. And this point I will just talk you through what is the lowest common multiple and how to find them. So lowest common multiple, which we call LCM. So LCM is the short for lowest common multiple. Now the lowest common multiple actually is defined as the smallest multiple that 2 or more numbers have in common. Yes, so all numbers are multiples of themselves. So for example, if I start with the number 5, 5 is a multiple of itself. All I have to do to get other multiples of 5 is to keep counting by 5. So 5, 10, 15, 20, 25, 30, those are multiples of 5. 6, 12, 18, 24, multiples of 6. So when we talk about the lowest common multiple, we're looking for the smallest multiple that would have been both common to 5 and 6, for example. So let's look here. Find the lowest common multiple of 25 and 35. So what we would have to do is to list the multiples of 25 and 35 until we found the smallest one. So in the interest of time, to get into our examples, I'm going to just use 2 smaller numbers. So 3 and 18. What if I wanted to find the multiples of 3 and 18? I would start by listing 3, 6, 9, 12, 15. So basically this is my timetable. Then 18. Then for 18, I would do 18. 18 add 18 is 36 and so on. But I stopped because I have found 18 to be a common multiple, which is the smallest one for both of them. So once I list my multiples of both numbers, the first one that appears common to both of them is my lowest common multiple. So that's what I'm after. Now you may ask, what if I use a multiple but it's not the smallest? Would I be wrong? And the answer is no, because at the end you could simplify and it would still take you back to your original answer. The key point here is that once you're dealing with fractions at all, you must always simplify to the lowest possible term you could have. Okay, so you could have recovered yourself. Okay, so here are two questions. Now we've got a fraction on both sides. This is where we apply the lowest common multiple principle. So we're asked to solve the equations where we've got x plus 1 divided by 3 as a fraction is equal to 2x minus 5 divided by 6 as a fraction. You will notice here that both fractions have a different denominator. This brings us to use the concept of the lowest common multiple and to get them to be the same. So what we need to do first of all is to identify what is the lowest common multiple of 3 and 6. A very nice and simple one here, because you should be able, if you know your timetables, to note that 3 can go into 6 and also 6 can go into itself. Therefore, if I should list the multiples, I would have 3, 6, 9. But for 6, I would have started with 6 itself and then get into 12. Therefore, 6 appears first in both multiple lists. So 6 is my lowest common multiple. Nice and simple there. So what we can do here now is to just write the lowest common multiple as our main denominator. Now I need to do 3 divided into 6. 3 into 6 goes 2 times. This means I need to multiply this numerator by 2. So I'm just going to put the 2 here. In brackets, I will put x add 1. So let's talk through that again. So 3 goes into 6 2 times. When I get that answer, I need to multiply it by the numerator of the fraction. Now, because this is an expression, I put the expression in a bracket to remind myself that I must multiply 2 by x and also 2 by 1, very importantly. Now, for the other side, I will have 6 goes into itself once. Now, 1 times the numerator still will be the same numerator, so this part of the fraction will not change. Now that the denominator is the same, 6 for both of them, I can now just go ahead and focus on 2 bracket x plus 1 is equal to 2x minus 5. Now what we need to do is to expand the bracket. So 2 times x is 2x, and 2 times 1 is 2, so that's positive 2. That's equal to 2x minus 5. I wonder if you notice what's going to happen in this question. Now, I specifically chose this question because most of the time you know what to do. You go in an exam and you see this and then you second guess yourself. So we know we should collect our like terms. So let's look at what happens for this question. I'm going to put my 2x here and my 2 to the right hand side. Now I will have 2x, this positive 2x will now minus 2x equal to negative 5, and this positive 2 will now be minus 2. So 2x minus 2x is equal to 0. So guys, we cannot have a variable term that cancels out to 0. Now, when this happens, so this would have been minus 7 here. When this happens, this means that this equation has no solutions because the variable term cancels out all the way to 0. So this equation has no solutions. When this happens, we say that the equation is undefined. Cannot be defined. So undefined. This is what you would have written in your exam. You would say the equation, take it all the way to where we've gotten here. The x terms would cancel out to 0, which means that this equation has no solution. You would then write the equation is undefined. We cannot find a solution for this at all. Very good experience for you to have. Absolutely brilliant. So this is possible. You get this in your exam. You're not incorrect. You just need to write that there are no solutions, which means that it is undefined. Absolutely fantastic. So what we're going to do now is go to our next question, where we've got 2x minus 3 divided by 4 plus x plus 1 divided by 2 is equal to 5. Brilliant. So what we're going to do here is to, as I always do, just rewrite the question, and then we need to find our lowest common multiple. Now, important to note here is that this whole number 5 has a numerator of 1. So good to do that. Very important to see this, that it has a numerator of 1. We could also have just concentrated on the fractional part first, and then when we find a simplification for that side, we focus on the rest of the equation. Okay, but we could recognize early on that every whole number has a denominator of 1. Now we need to find our lowest common multiple of 4 and 2. So again, we see that 2 goes into 4 and 4 also goes into itself. Absolutely fantastic. So the lowest common multiple therefore is 4. So we go and divide this denominator. 4 divided into 4 goes once, so this part will not change, since 1 times by 2x minus 3 is still 2x minus 3, plus 2 goes into 4 2 times. We then need to multiply this 2 by the numerator, which is x plus 1, and that's equal to 1 goes into 4, so this denominator 1 goes into 4 4 times. 5 times by 4 is 20. Beautiful. So what we need to do now that all of the fraction has the same denominator, we will just take the numerator and make it equal to 20. I'll talk you back through this and then summarize. So 2x minus 3, and then we've got 2 times by x, which is 2x, and 2 times by x is 2x, and 2 times 1 is 2. And all of that is equal to 20. So we do not need the denominator, since we have now neutralized everything and make them compatible. We can now add them together, and we do not need the denominator. So let's collect like terms. 2x plus 2x is 4x. And minus 3 plus 2 is minus 1, and that is equal to 20. So we need to add 1 to both sides. So 1 and minus 1 cancels out to 0, so 4x is equal to 21. Last step is to divide by 4 on both sides. So we know 4x divided by 4 is equal to x. So x then is equal to 21 quarters, or we could get a final answer for 21 quarters. So 21 divided by 4 is 5.25 for our solution. Beautiful. So again, you will see here it's very important to be able to manipulate our fractions. Key principles: denominators are not the same. We must first of all find the lowest common multiple. Once we find the lowest common multiple, we will just take the numerators and solve the equation as we normally would. So first thing we did, find the lowest common multiple of 4, 2, and 1 was 4. 4 into itself goes once. 1 times 2x minus 3 remains the same, 2x minus 3. 2 into 4 goes 2 times. We must multiply that 2 by x, add 1, and then 1 into 4 goes 4. 4 times 5 is 20. Now that we've neutralized this with the same denominator, we take all the numerator and make it equal to 20. Then all we do, collect like terms, simplify and solve for x. And again guys, you can substitute this answer and see if when you've completed the fraction, your answer should be 5. Brilliant. Now I would suggest you go back through this again so that you solidify this skill of solving equation involving fractions. I will also do a series on fractions on a whole, simplifying fraction by adding, subtracting, multiplying, dividing, and so on. So in time to come, I will upload fractional lessons as well for those people who need to solidify their fractional skills. Absolutely brilliant. Guys, we are making some progress here. This is our third section on our solving equation lessons. We've got one more to go, so make sure that you're looking out for that. So, wrapping this up, remember fractions are division and must be treated as such. So when we're solving our fractional equations, step 1, we remove all fractions first. Sometimes we will have to find our lowest common multiple. We then move all brackets. Once we have a bracket, we remove those, then we combine like terms. Next, we solve for the variable in question. Could be x, could be y, could be any letter at all. And we always do the inverse of our operation. Once we've done that, we can simply do a rough calculation to make sure our answer is correct. Absolutely brilliant. So guys, thank you for getting to section 3 to the end, and remember you've got practice questions which you can find in the description of this video. Until I've uploaded the final section, thank you so much for watching.